At time t seconds, where t is bigger or equal to 0, a particle p moves so that its acceleration, a meters per second squared, is given by, so a is 1 minus 4t I plus 3 minus t squared j, and we're told at the instant when t equals 0, the velocity of p is 36i meters per second. We need to find the velocity of p when t is 4. So we've got the acceleration, we need velocity. So we're going to need to integrate acceleration to find velocity. To remember that, we can say for a velocity time graph, if we want acceleration, we find the gradient. So the gradient of a velocity time graph is acceleration, and to find the gradient, we differentiate. So to go back from acceleration to velocity, we do the opposite of differentiating, which is integrating. And it's the same from a velocity time graph. To find the displacement or the distance, we find the area underneath, which is found by integrating. But if we have displacement and we want velocity, we do the opposite, which is differentiating. So we've got the acceleration, we need the velocity, so we are integrating. So the velocity is, so for each of these, we're going to add 1 to the power and then divide by the new power. So for 1, it's going to become t minus 4t, add 1 to the power, will become a t squared, divide by the new power, 4 over 2 is 2, so minus 2t squared. That's our i's. Same for the j's. So 3 will become 3t, and minus t squared, add 1 to the power, will become t cubed, divide by the new power, divide by 3, or you could write 1/3. So either t cubed over 3 or 1/3 of t cubed. That's our j's, but when we integrate, we also need to plus c. And to find out what c is, we've been given this extra bit of information. So when t is 0, velocity is 36i. So when t is 0, we're going to have, well, 0 i's plus 0 j's plus c. So when t is 0, v is 36i, and that must be c. So 36i must be our c. So we can say the velocity is t minus 2t squared I plus 3t minus 1/3 t cubed j plus 36i. And we can bring these i's together as well. So we've got t minus 2t squared plus 36, and they're all i's. So we could say we've got t minus 2t squared plus 36i, and we've got 3t minus 1/3 t cubed j's. We need the velocity when t equals 4. So we just need to substitute in 4 for t. So we'll do it separately for our i's and our j's. So let's substitute in 4 for t. So we've got t, which is 4, minus 2 times 4 squared plus 36. So that's 8. That's 8 i's. And for our j's, we've got 3 4's minus 1/3 of 4 cubed, which is minus 28 over 3. So there's our velocity when t equals 4. Part B, find the value of t at the instant when P is moving in a direction perpendicular to I. So the I direction is the positive X direction, straight to the right. Perpendicular is a 90-degree angle to that. So what happens when we move perpendicular to I? Well, we're moving in the J direction, and it means the I's are 0. If we're only moving in the J direction, we must have no I, no left and right component. So we need to find T when the I's equal 0. So when the I's, which is T minus 2T squared plus 36 equal 0. We want to know what T is when I equals 0. So we need to solve this quadratic. We can solve it by we could get it over to one side, which it already is, factorize, or we could use the calculator. So menu, equation or function, polynomial, order 2, quadratic. We've got minus 2 x squareds or t squareds. We've got 1t, and we've got 36 as our number. So we've got 9 over 2. So t is 9 over 2. Or we have negative 4. We can't have negative 4 because t was bigger or equal to 0. So t is 9 over 4, or 4.5 seconds. It's the second part. At time t seconds, where t is bigger or equal to 0, a particle q, so a different particle, moves so its position vector, r meters, relative to a fixed origin O, is given by r, so this is the displacement this time, t squared minus ti plus 3tj. Find the value of t at the instant when the speed of q is 5 meters per second. So this time we've got displacement, we need velocity, so we're going to differentiate. So we're going to find the velocity first. So r is t squared minus ti plus 3tj. T squared minus ti plus 3tj. So that's our displacement. We want velocity, so we're differentiating. So times by the power, take 1 off the power. So times by the power, take 1 off the power. So 2t minus 1i, and we just got 3j. That's velocity. We don't want velocity, we want speed. So to go from velocity to speed, we don't want i's and j's, we just want how long the line is. So 2t minus 1i, so 2t minus 1 in the I direction, 3 in the j direction, but we want the length of this hypotenuse. Or we know the length of the hypotenuse, even, the speed is 5. So we can use Pythagoras to find t. So 2t minus 1 squared plus 3 squared equals 5 squared. We can use Pythagoras. So 2t minus 1 squared plus 3 squared equals 5 squared. So let's expand the brackets and then make it equal to 0 and then solve the quadratic. So 2t minus 1 squared is 2t minus 1 times 2t minus 1, and I'll change 3 squared to 9 and 5 squared to 25. So expanding the brackets, 2t times 2t, 4t squared, 2t times negative 1 is negative 2t, negative 2t again, A negative times a negative is a positive. So -1 times -1 is 1. So collecting the like terms, we have 4t squared minus 4t plus 10 equals 25. And to solve the quadratic, we want it equal to 0. So take 25 away from both sides. Now let's type it in the calculator. So we've got 4t squared minus 4t minus 15 equals 0. So we've got 5 over 2 or negative 3 over 2. We cannot have a negative time. It's got to be bigger or equal to 0. So it's 2.5 seconds.